Good evening, everybody. Welcome back to this lecture on Big Data Analytics. We have completed already two subsections under the module of Introduction to Big Data Analytics. They were on an introduction for the need for what is meant by big data and why big data is required. The second module was on basically the architecture and characteristics of big data systems with the use case. The third lecture is on the life cycle of a big data analytics system. What are all the different phases? Whether the traditional software engineering life cycle can be used with a case study. So this is the basic agenda for the presentation. It involves the various cycles, phases in the big data analytics life cycle. It includes the business case evaluation with the data filtration, extraction, and aggregation representation phases to convert the data into a particular format so that a model can be built, and then the results can be communicated to the different stakeholders and the deployment of the model can take place. Finally, this cycle is analyzed for a sample application on stock market analysis. If you consider the traditional software engineering lifecycle cannot be used because of the inconsistency and the ambiguity that is inherent in the data science projects. So this is the life cycle that is followed, which consists of three major phases. The first phase is business case evaluation phase, where the basic requirements are being obtained. Then the data analysis phase, where the data is converted into a particular format suitable for representing the model. Then the model is planned and then it is built. Finally, it is communicated to the different stakeholders. Once they agree on it, the model is being deployed. So it consists of three major phases: business case evaluation phase, the data phase, and the model building phase. So these are the three basic phases. We will discuss that in detail. As I have already explained to you, these are all the different phases. The first phase is business case evaluation phase, which mainly aims at drafting a plan and identifying the stakeholders and reviewing the same, whether it is a data science project and so on. Then in the data phase, we have all these subphases, which include data identification, which involves identifying the sources of data and obtaining the data sets, data acquisition and filtering, which transforms and filters the incoming data, raw data, so that it is suitable to form the model. Data extraction phase, it extracts the attributes which are suitable for forming the model. Data validation and cleansing phase, that is used to remove all the invalid data and fill in the missing data. And data aggregation phase, since it is a data science project, data is obtained from multiple sources, they have to be merged, and then the data has to be analyzed and the model has to be formed. So now the data is converted into suitable format for building the model. So the other phases deal with identifying and building of the model. So the analytic modeling phase has two main subphases: planning and building of the model. The models can be either exploratory model, which is used to identify the characteristics of the data, or confirmatory model, which is used to form and give the final results of analytics. The results are communicated to the various stakeholders, and then once they are satisfied, the model is deployed in the production environment. We will see about the business case evaluation phase. The basic objective of the phase is to identify the business domain and to form the goal of that particular project, who are all the stakeholders, and what are all the budget requirements of the project. Now, one of the important activities done in the business case evaluation phase is assessing and approving whether the given problem is a big data problem by identifying whether it satisfies at least the 3 basic B's of big data characteristics. Then a hypothesis framed based on which the problem is being tested. The stakeholders are identified along with their role. A peer review is conducted to see that the people agree that, or the stakeholders agree that it is a big data problem and the hypothesis is correct. So this is the basis of the business case identification problem that mainly identifies the objectives and the goal of that particular project, identifies the stakeholders, identifies whether that particular data has big data characteristics, verifies it with the stakeholders, and then identifies the budget of the project along with the framework and the sources of data. The second phase to the sixth phase involves extraction of the data into a particular format so that the model can be built. So the first of this is the data identification phase, which identifies the sources of data. Then it assesses the characteristics of big data and validates the data source and as well as the scope, the amount of the data as well as the framework that can be used for storing of this particular data. So that is the purpose of data identification phase. It identifies the sources of data, whether it has the characteristics of big data, as well as it identifies the and validates the scope of that particular data. Next is the data acquisition and filtering phase. The purpose of this phase is once the data is got, all the noise has to be removed from the data, depending upon whether real-time analytics or batch processing analytics has to be done. The data is being stored in the storage device. If it is a real-time analytics, then analysis is done and then the required data is stored in the storage device. So the third phase is how to acquire the data depending upon the type of the application, whether it is batch processing or real-time, and to filter out the noise and the unnecessary data. So that is the purpose of this particular phase. It also extracts the metadata to identify the characteristics of data. This phase is a very important phase because the model is framed from the filtered data and it consumes a lot of time. Especially if you consider in the credit card fraud detection, since it's a real-time application, the analysis is done on the credit cards which outlier characteristics, and then the data can be stored. Then the next phase is data extraction phase. What are all the attributes of the data that is necessary in order to create the application is extracted from the data extraction phase. For example, in a recommendation system, if location-based recommendation is to be given, so the location attribute of latitude and longitude is important. So that is being extracted in order to give the recommendation suitably. So extraction depends upon the type of application and it is also platform dependent. Next phase is data validation and cleansing phase. We have data from multiple sources. For example, this first table tells about the patient table. The second table is the doctor table. There should be an integrity between the patient table and the doctor table. So, for example, if we consider This Ram doctor looks after patients 123 and 134. So the patient ID should coincide with this particular table. So that type of data validation is being done, and whichever is not a valid data is being cleaned or removed. So once validation and cleansing is correct only, then in that case, the model formed will be correct. If we consider a stock market application, there are spikes depending upon the external as well as man-made calamities. So these spikes will make the prediction of the stock market prices wrong, because these spikes are outliers. They have to be removed. So such type of cleaning is done in this fifth phase. Once the data is cleaned, data is coming from multiple sources. They have to be aggregated to and then formed as a single logical view. For example, a customer's home address may be present in one table in a particular format. It may be stored in a relational store. The work address may be present in another table or a data store in key value format. The data from both these stores should be extracted and a logical view can be formed so that the data regarding a particular customer can be maintained in a single logical view. That is the purpose of data aggregation. Once the data is aggregated, now the data is ready to be used for the modeling phase. We will see what are all the tools that can be used in different phases. During the storage, we make use of Flume and Kafka. Flume is used to collect the data, and Kafka is used to queue the data to the storage device. ETL is done by Flume and Kafka is used for maintaining the message queues. During the ETL, data wrangling or munging is being done, where the data is cleaned and then the data is stored into the storage device. Once the data is stored into the storage device, different type of processing can be done by different type of tools. For extracting the characteristics of the data, languages as well as tools are available, starting from Alpine Miner to Python to extract the characteristics of data, based on which some operations can be done. Now, up till the past phase, we saw the data is transformed and aggregated into a particular format so that the model can be formed with suitable attributes. So in the analytical modeling phase, we have to form the model. It has to be verified and then it has to be deployed. So that is what is done in the analytic modeling phase. Models can be of two types. They can be either confirmatory or exploratory in nature. Exploratory is used to extract the characteristics of data, whereas confirmatory is the final model that can be uploaded into as a deployment model into the framework. So this is the difference between exploratory analysis and confirmatory analysis. There is no clear hypothesis stated, whereas here a clear hypothesis is framed, and at the end, after deployment, it is being checked. It does not answer whether the hypothesis is satisfied or not. This answers whether a hypothesis is satisfied or not. It helps to identify the patterns of data, whereas this is used to give the actual results. So this is the difference between exploratory analysis and confirmatory analysis. So in this phase, it involves basically model planning and model building. During model planning, exploration of the data is done to identify the attributes, the characteristics of the attributes, the linkage between the attributes, Once it is done, a suitable model is being built. To build the model, it has to be selected from the set of models either specified by the data scientist or an analyst who chooses a suitable model. So this forms a model planning phase after exploring the data. So once the model is identified and the data characteristics are identified, the model is being built, making use of different platforms or tools or languages. And once it is built, it is being evaluated with test data. This result is then shown to the customer or the stakeholders who agree on the model to see on the failure or success of their hypothesis and to identify whether the business objectives are satisfied or not. The results are communicated to the stakeholders using suitable visualization tools. Finally, if the stakeholder is okay, business user is okay, then the model is deployed in the production environment, and then the actual data can be given as input to this model to predict the results. So that is the purpose of deployment. So these are all the 9 phases in the big data analytics life cycle. The first phase tries to identify the business problem and to characterize and to identify the stakeholders and their roles, the characteristics of the data, whether it is actually a big data problem. All this is identified in the business case identification problem. Then the next phase is up till the 6th phase involves converting the data into a particular format so that the model can be built. This involves gathering of the data, filtering the data, extraction of the attributes, aggregation of the data into a particular format. Once these phases are completed, then the model planning and the model building phase occurs. During model planning, data exploration is being done. Using this characteristics of the data, the model is being built and it is being deployed. The results are then communicated to the customer or the business user. Once he identifies that the objectives of the problem is satisfied, then he feels that the model can be deployed. Then finally, the model is deployed in the production environment and the input data is given to predict the results. So these are all the 9 phases in the big data analytics life cycle. Now we will see this with a particular case study. Here the case study considered is a stock price prediction case study. How to predict the price of stocks from the history of the data which is available online from different sources. So the first phase is the business case identification. This basically identifies what is the problem, what is the need for stock price prediction, why should you do stock price prediction, what is the domain to which this particular problem belongs to. It belongs to the financial domain. What are the sources of data that are available? Data can be got from Yahoo Stock Exchange, BSE or NSE Stock Exchange. What type of framework can be used in order for the prediction? Who are all the stakeholders who are involved? Why should such a problem be analyzed? The basic purpose is prediction of the stock prices helps to minimize the losses for the customers. What is the goal of the problem? To predict the stock prices using machine learning techniques. What are all the data sets? Whether they have the characteristics of big data or the 3 V's of big data. What are the key performance indicators? They are the accuracy and the speed. So once the business case with all the stakeholders, whether it is a big data problem, the source of the data has been identified and the goal of the analytics is identified. Next, we go on to get the data from which the model can be built. In this, the first is identification of the source of the data. As we have already seen in business case identification itself, BSE, NSE, stock exchanges can be made use of. The data can be obtained from this. It can be cleaned and unnecessary data can be removed. Next is filtering of the data. The data is ingested from different exchanges. Metadata is extracted and then unnecessary spike data, everything is removed. And depending upon what type of prediction is done, whether hourly data, weekly data or monthly data has to be obtained. Then the metadata, depending upon the name of the company, the date of the sale, what is the high price and low price of the stock, what is the opening and closing price of the stock, and how much volume of the stock has been sold during the date. This is the metadata that is extracted for monthly purchase. Next, once the data is acquired, the important attributes have to be extracted from the data. This is done with the help of a domain expert. Stock market predictions can be done with the help of two attributes, moving average and relative strength index. These two are the attributes. So these two attributes are being calculated based on the closing price as well as on the upward and downward movement of the stock price. Once the data is extracted, the next feature is we have to validate and clean the data. Some of the validation techniques include, if the denominator of this RS, that is, there is no downward price changes, RS becomes infinity. So in that case, we have to either include another month's data or we have to discard that particular data. Similarly, spikes in the stock prices based on some natural or political disasters has to be eliminated so that stock prices can be identified or the modeling can be done correctly. So this is the purpose of data validation and cleansing phase. Once the data is validated and cleaned, the aggregation of the data has to be done. Since the data is from different sources or from different exchanges, the data will be in different format. So it has to be aggregated into a common format and then the data can be stored in Hadoop distributed file system for further analysis. So after this, whatever data is there, it is converted into a particular format which is suitable to building of the model. The other phases involve construction of the model and testing of the model. So here, different types of machine learning techniques or classification techniques can be used. One of the techniques that has been demonstrated is using support vector machines. So this type of multi-class SVM has been chosen and hyperplane is being constructed and BD tree type of a classifier is being made use of. So here, since parallel storage of data as well as analysis on data has to be done, map-reduce version of the support vector machine is being designed. There are two basic phases in this map-reduce version. The first phase involves the map phase and the second involves the module involves the reduce phase. The map phase is used to do the operations in parallel and the reduce is used to aggregate the results of the operation. For example, calculation of the moving average and relative strength index for different months can be done in parallel and the results can be aggregated for all the months. And then based on the movement of the stock prices, the points can be classified as positive and negative points. So this forms the first cycle of the map reduce. In the second cycle, the support vector machine construction takes place, where the positive and negative points, the support vectors are being calculated using the map phase, and in the reduced phase, the hyperplane is constructed. Once the hyperplane is constructed, then the BD tree type of the classifier can be constructed. Using it, a test data can be given as input and the result can be predicted. So this is a type of research that has been done in order to construct to construct a support vector machine and to classify or to predict the data, making use of certain ranges of upward or downward changes in stock prices. Next phase is, once the model is done, some test data can be given as input and the results can be predicted. So these results have to be shown to the business user so that he is satisfied with the performance of the system. So table format as well as the graph format of the result is shown to visualize it. Here the light gray shows a predicted and this is the actual value. This shows the performance of the system is shown to the business user, and once he is satisfied, finally the model is deployed on the Hadoop cluster in the Amazon cloud. So this is a use case of predicting the stock market prices using business analytics life cycle, and what are all the operations that take place in each phase of the big data analytics life cycle has been clearly explained in this slide. Initially, we considered the 9 different phases of the big data analytics life cycle. What is the functionality of each phase? Then we explained what all operations can take place in each of the phases by considering a sample use case of stock market prediction, price prediction. I thank you all for joining this lecture on Big Data Analytics. We have completed on Module 1 of Big Data Analytics. Thank you very much.